So question number 16 here is a variation of what I'm asking, one of the questions I'm asking you on in WebAssign for the week. So I because this is something that somebody could respond to and earn for attendance points, I don't really want to answer that one. But what I will do is I'll do a video for number 15 now, because that's got a star next to it. You can go into Canvas, go to course resources, and then there's a file in the course resource module, or modules course resources. And that course resources module is a file that says detailed solutions TD for ThinkDo. So, go check those out. That's helps you. Doing these questions before you try WebAssign will make your WebAssign work go a whole lot faster. Okay, that's my recommendation. I know people don't do it, but that's okay. So, now we're into a binomial. This is all about binomial distributions. Well, some things we should do. We want to make sure this is a binomial distribution, besides having the textbook tell us it is. So the conditions, there's 4 conditions it has to satisfy to be a binomial experiment, say, binomial distribution. So I've got to have a fixed number of trials, and we're looking at 130 people. Same thing down here. We're looking at 250 people, okay? So that's fixed. It's a yes/no answer. So did somebody die? Let's see. I suppose with this type of okay. So was somebody still alive 5 years after diagnosis? So that's yes, they were alive. No, they had passed away. So a yes/no answer. The probability that whether I have that cancer and passed away, or you have that cancer and passed away, doesn't affect, where we're independent, our results are. And then our probability of dying from this, living, did not die. So probability of living is about 75%. And whether my 75% doesn't affect your 75%. So this is a binomial experiment, because it passes those 4 things. The other thing we're going to check for that is this a symmetric distribution? Because remember, back in Chapter 2 and Chapter 3, we could use the mean and standard deviation to describe the center of spread of a symmetric distribution. So that's why Dr. Stevens has this stuff in here, because if this is true, it's going to be more or less symmetric. Okay, so let's do that check. Let's see. So I've got n is 130. And the probability that somebody survives is 75%. Well, that's more than 5, right? So I'm not even going to bother finishing that. And then 130 times a failure, which is 0.25. 1 minus q is 1 minus p, right? And a quarter of 130 is also bigger than 5. So yeah, we've got a symmetric distribution going on here. It's a binomial experiment, so we're good to go. We can apply these techniques. So for part A, what's the mean? Well, the mean of a binomial distribution is found by taking the how many trials times the probability of success, which we kind of already did up there. Of course, I never actually calculated that number. So 130 times 0.75 is... what did I get? I got 97.5. That's 97.5. And then to get the standard deviation of a binomial distribution, the formula is take the fixed number of trials times the probability of success times the probability of a failure. So we've already done n times p, right? 130 times 0.75. So I know that's 97.5, but I'll fill in the formula in case somebody's a little lost. And then 1 minus p is 1 minus 75, or 1 minus 0.75, which is 0.25. And then we multiply those 3 numbers and take the square root. So I know that this part is 97.5. I'm going to times that by 0.25. I got 24.375. And then I got to take the square root. And what does that give me? That gives me what? I got 4.9-ish. So the standard deviation is 4.9. So just kind of tell you where we're going with this. I see a normal distribution with a mean of 97.5 and a standard deviation of 4.9. Okay, so I've done. Let's make sure I've answered these questions here that it wants me to. What's the mean? What's standard deviation? Did 85 survive? Is that unusual? So I got to do a z-score, right? I mean, that's how we do unusual. That's how we use. That's the outlier test, right, for means and standard deviations. So let's calculate the z-score. So what was it? It was 85. So 85 minus 97.5 divided by the standard deviation of 4.9. So let's see, 85 minus 97.5 is negative 12.5. If I did that right, yes, I did that right. And then I'm going to divide that by 4.9. I'm getting negative 2.55. So is it unusual? This is more that result of only 85 people surviving has a standard deviation, is more than 2 standard deviations away from the mean. So yes, it is an unusual result, and something needs to be checked into about this. Okay, and that's where we're going to go in chapter 8. We're going to formalize this into a significance test is where we go. Okay, but that's how you do that. Now this number 16, same kind of work. You just got to whoops. Let me undo that. Can I delete some of this stuff? Let's see. Just so I can see the problem. Yeah, so you're going to do the same kind of thing. Mean, standard deviation. Use those same formula. Do the check. Make sure that this is true. Make sure that it's a binomial distribution. Also, it is because he gave it to us in that section. But make sure you do that, and then calculate the mean using that n times p. Calculate the standard deviation by n times p times q, or 1 minus p, and take the square root of that. Some people have trouble with the square root. Remember, x squared is not the button you want to use. Probably over it is the square root button. Okay, depends on your calculator. If you're in a spreadsheet, you can say SQRT of of those numbers. Okay, that'll do equals SQRT. And you can also use that histogram applet that I've used. Okay, that binomial probability histogram that's in the course resources. Okay, so hopefully this helps.